Limit as y goes to pi over 4 of the cosine of y minus the sine of y over the tangent of y minus 1. The first thing I'm going to do is try plugging a pi over 4 in for each of the y's. That'll give me the cosine of pi over 4 minus the sine of pi over 4 divided by the tangent of pi over 4 minus 1. The cosine of pi over 4 is root 2 over 2 minus the sine of pi over 4 is root 2 over 2 divided by the tangent of pi over 4 is root 2 over 2 over root 2 over 2, which is a 1 minus 1. Root 2 over 2 minus root 2 over 2 is 0. 1 minus 1 is also a 0, and we have the 0 over 0 indeterminate form. It's resulting from trig functions. None of them are squared, so we don't have a Pythagorean identity. None of them have a 2y, so we don't have a double angle identity. But we can change the tangent into sines and cosines. Let's try that to see if we can maybe get a factor and cancel. So we would have cosine of y minus the sine of y. I'm going to leave that alone over the tangent, which is sine of y over cosine of y, minus 1. We can get a common denominator between those two terms in the denominator. I need to multiply that 1 by a cosine of y over a cosine of y form of 1 to turn it into a fraction with a common denominator so that I can combine those fractions together. So I have now the cosine of y minus the sine of y divided by the sine of y over the cosine of y minus the cosine of y over the cosine of y. And they can now combine over the common denominator by subtraction. So I have the cosine of y minus the sine of y divided by the sine of y minus the cosine of y over its common denominator of cosine of y. So we have a fraction in the denominator. The next step is to reciprocate and multiply that fraction in the denominator with the numerator. So I will have cosine of y minus sine of y quantity times the reciprocal of the denominator, which is cosine of y over the sine of y minus the cosine of y. And now I'm going to actually multiply those. We can put the first expression over a 1 to make it look like a fraction for fraction multiplication. You multiply the numerators. I'm not going to distribute that cosine of y, though, because I have a common factor in the numerator and denominator. In the denominator, I have 1 times the sine y minus the cosine y. And the common factor in the numerator and denominator is the cos y minus sine y, or sine y minus cos y. They're actually opposite signs of each other. But they are what is making 0 over 0 here. If you plug in pi over 4, each of those are root 2 over 2. And we need to get them to cancel to remove the 0 over 0 indeterminate form. So the next step is to factor out a negative from one of them. It doesn't matter which one. I will just opt for the numerator here. And the negative will just be in the front, and that's going to make the sine y become positive and the cosine y be negative, so that it matches perfectly what we see in our denominator, which is also sine y minus cosine of y. And those factors can cancel. And after canceling, we are no longer a 0 over 0 indeterminate form. All we have left now is a negative cosine of y, and we can plug in the pi over 4 for any of the remaining y's. So I have the negative of cosine of pi over 4. The cosine of pi over 4 is root 2 over 2, so we have negative root 2 over 2.